Now, after learning about polynomials, their degree and zeros, now we are interested in division of polynomials. Okay, so here I have taken a simple polynomial px, which is x plus 3x square minus 1, and gx 1 plus x. Now we want to know what will happen if px is divided by gx. Okay, in earlier classes we have learned how to do the long term division of polynomials. Okay, so here also we can do it, but before doing it, what we will do, we will arrange our polynomials in standard form, right? So first you can write it like this: gx will divide what? Px. So let us write gx first in standard form. It will be like x plus 1, and our px in standard form will be 3x square plus x minus 1. Okay, now we have written our polynomials in standard form. So let us divide it now. So in long term division, what we do, we check the first terms of both polynomial and divide the first term of the px by first term of gx. It will give you 3x, right? So you write it as 3x square, and then we multiply the other terms of gx by the same term. So 1 multiplied by 3x will give me plus 3x, right? What we will write here, opposite signs of the last terms. So it will give you 0, and this plus minus will give me minus. Minus 3x plus x will give me minus 2x, and minus 1 will come down, right? Next again we will check the first terms, x and minus 2x. So here it will be minus 2. So minus 2x plus 1 minus 2 is minus 2. Opposite signs cancel out. Plus 2 minus 1 is 1. Okay, so in this long term division, what is this called? This is called as quotient, right? This is what? My remainder, right? And this is what? Division. This was my dividend. Okay, so this is a long term division of polynomial, right? Okay, let us take another example, and we will do it again by long division method. Okay, so here my px is x cube plus 1 and gx is same, x plus 1. Okay, so let us see how to divide it. We can write px in our, it is already in the standard form, but here there are some missing terms, like x square is not there, x is not there. So let us write it in index form, which says x cube plus 0x square plus 0x plus 1, right? So what we have done, we have written our px in index form. Okay, now we will divide. This gx is in index form only, right? Standard form as well as index form. So now let us divide. First term, it will be like x square, x cube, opposite signs cancel out. It will be minus x square plus 0x plus 1. Why minus x square? Because it is minus x square plus 0. Then it will be minus x, then minus x, opposite signs cancel, plus x plus 1 plus 1, right? So this is my quotient, this is my remainder, divisor and dividend. Clear? So this was my long term division method. Now we will learn about another method which is known as synthetic method. Okay. Now synthetic method is applicable only when our gx is of the form of x plus a or x minus a. Right? If my divisor is in this form, then only we can apply the synthetic method. How to do this? Let us learn it about. Okay. So what we will do here, first, what is the coefficient form of this? Coefficient form of this px will be 3, 1 and then minus 1. Alright. So what we will do, we will make 3 rows. Okay. First row, second row and then third row. Okay. In the first row, we will write all the coefficients of our polynomial px. Okay. And here what we will write, see, gx is equal to x plus a, right? So here what you do, just put gx is equal to 0. So x plus 1 is equal to what? 0. So your x value will come as minus 1. Write it here. Okay. Similarly, suppose if gx was x minus 1, then suppose it is x minus 1, put it equal to 0, it will be 1. So whatever the value of x comes after putting gx is equal to 0, write it here. Okay. Or you can simply conclude from here also that if plus a is there, it will come as minus a will be there, it will come as plus a. Okay. Now let us learn the synthetic method. The first coefficient will come as it is, the third row. My answer will be in the third row, right? So the first coefficient will come as it is. Okay. And then what we will do, we will multiply this 3 and minus 1 and write in second row minus 3. Right? Understand this. First coefficient as it is, then multiply 3 by minus 1, write it under the second coefficient, and now add these two coefficients. 1 minus 3 will be minus 2. Since we are adding a positive and a negative number, it will be a subtraction. So 1 minus 3 will give you minus 2. Next, now multiply minus 2 by minus 1 and write it here. It will be plus 2. Minus 2 multiplied by minus 1 will give you plus 2. Again, add these two numbers. So 2 minus 1 will give you 1. Right? Now this last row is basically my quotient and remainder. The last number is my remainder. Right? And we started with, our polynomial is starting with what? X square. So we will take one less power, like it will be x, and x to the power 1, here x raised to power 0, and multiply this. It will be like 3x minus 2. This is my quotient. So this is the synthetic division, but only when our gx, which is divisor, is in the form of x plus a or x minus a. So we can do in this method also, and my answer will be all the coefficients are here with one power less, and then in decreasing order of variable, and the last number will be what? The remainder. Okay. Okay, let us do it for second example also. Okay, synthetic division again. Here, if you write the coefficient form, we have px is x cube plus 1. So your coefficient form is 1, then 0 for x square, 0 for x, and then 1. So this is my coefficient form. Okay, so let us make 3 rows here, and for the first row we will write like this. Value is -1 here. First element as it is, multiply 1 minus 1 will give you what? -1. Add this -1, multiply -1 by -1, plus 1, 0 plus 1, then multiply 1 by -1, add these 0. So my quotient will be, we started with x cube, so here it will be x square x and the constant term, this is what? The remainder. So quotient will be x square minus x plus 1. Correct? Now we will learn about another concept, which is remainder theorem. As the name suggests, we will get the remainder from this theorem. Okay, so let us take our first example. As px is this and gx was x plus 1. Again, what we need to do, we need to put gx is equal to 0 to get the value of x. So here we will get x is equal to -1. Now we can put this value in our polynomial to get the remainder directly without doing any division. Okay, so we write this polynomial as p minus 1. Why p minus 1? Because we are replacing x by -1. So it will be like 3 minus 1 square plus 3 minus 1 minus 1. So it will be -1 square is what? 1. 1 multiplied by 3 is 3. Minus 3 minus 1. 3 will cancel. So remainder is -1. So without doing any division, we can find out the remainder, but only in the case where gx is a linear polynomial and we can get a single value of x by putting it is equal to 0. Right? Let us do for second example also. What was my second example? Second example was x cube plus 1. Right? Again, our value of x will be -1. After putting it is equal to 0, then p of -1 is -1 cube plus 1 0. Right? So without doing any division, what are we getting? We are getting the remainder of the polynomial. This is called as remainder theorem, that if you divide a polynomial px by a linear polynomial gx, okay, and if you just equate gx to 0 to find the value of x, and that value, if you replace that value in the original polynomial, you will get the remainder. Okay. Now let us learn another concept, which is factor theorem. It is similar to remainder theorem. Okay, suppose if we divide a number 6 by 2, simple division, right? So my remainder is what? 0. Now if the remainder is 0, we can call this 2 as a factor of 6. We can write 2 is a factor of 6. It is a definition of factor, that a factor basically what? It divides the number exactly, right? So remainder is what? 0. So if by remainder theorem, suppose suppose there is a polynomial px and we are dividing it by gx, and if you put gx is equal to 0, you get value as x is equal to a, some number a, and then putting it back to the original polynomial. If pa, the value of pa is 0, then we can say that gx is a factor of px. This is called as factor theorem. So what you need to do, you need to just check the remainder. If remainder is 0, if r comes at 0, we can say that gx is factor of px. If r is not equal to 0, then gx is not a factor of px. That's it.